Hello students, now I am going to discuss model question paper and the subject name is data communication and computer networks. First I am going to discuss the part A questions, and the first question is what is mean by data communication and computer network. Let's see the definition first. Data communication. So data communication are the exchange of information between two devices. What we exchanging? Message or information. This message may be text, audio, video or anything. This message is exchanged between two devices. Devices are computers, workstations, and etc. So data communication are the exchange of information between two devices. It requires some medium, right? So via some form of transmission medium such as wire, cable or wireless. So under wireless, with the help of coaxial cable, twisted pair cable, and wireless with the help of radio waves, microwaves, infrared, and so on. Finally, the data communication are the exchange of information between two devices via some form of transmission medium. This is called data communication. Next, computer networks. What is computer network? So computer network is a collection of autonomous computers interconnected by a single technology. So it is a collection of computers that interconnected by one single technology. It is called computer network, and this carry 2 marks. Next question is what is jitter? So jitter in computer network refers to variation in packet arrival time. Variation in the packet arrival time. And it also referred as uneven delay in the delivery of audio or video packets. In the delivery of audio and video, this is audio and video packets. Let's see with example. For example, if the video packets are sent with every 30 minutes. So what we are sending, the video packets are sent with 30 minutes. If some packets arrive with 30 minutes delay. If some packets, the video packets comes with or arrive with 30 minutes delay, and other video packets arrive with 40 minutes delay. So what is the quality? The uneven quality is the result. So Jitter is the variation in packet arrival time. Means it is the uneven delay in the delivery of audio or video packets. This is called jitter, and it is one of the characteristics of data communication. Next question is, write any two disadvantages of mesh topology. This is the diagram of mesh topology. In mesh topology, each host or each device is connected to one or multiple devices or hosters, and in this topology there is a point-to-point connection with every other hosters. This is mesh topology, and let's see the disadvantages of mesh topology. So mesh topology requires high number of cables and input output port for the connection, because every host or every device is connected to one or multiple hosters, so requires high number of cables and input output port. And the next one is installation is very difficult. Installation is very difficult in mesh topology because each node is connected to every node, so installation is very difficult. And the next one is mesh topology is costly. Mesh topology is costly compared to other network topology. The mesh topology is costly compared to other topologies because the number of input output ports and cables requires more in mesh topology. So this is the disadvantages of mesh topology. Next question is, what is unguided media? Give two examples. So unguided media transmits the electromagnetic waves without using any physical medium. Means it does not require any physical medium, whereas in guided media, with the help of physical media, that transmits. In unguided media, transmits the electromagnetic waves without using physical medium. And unguided media is also known as wireless communication. It's also called wireless transmission. And in unguided media, air is the medium, transmission medium, whereas in guided, the cables are the medium. Here air is the medium through which electromagnetic energy can flow easily. So here air is the medium through which electromagnetic waves can flow easily. And examples for unguided media are radio waves, microwaves, and infrared waves. These are the examples of unguided media. Next question is, what is attenuation and delay distortion? So attenuation and delay distortion are the transmission impairments. These two are transmission impairments. Transmission impairment means when signals travels through the medium, they tends to interrupt with some other reasons. Attenuation and delay distortion are one of them. So let us see what is attenuation. Attenuation means loss of energy. So when signals passes through the medium, when signals passes through the medium, they tends to get weaker. So when the signals passes through the medium, that tends to get weaker. As it covers distance, it loses its strength. As it covers distance, it loses its strength. Means for the receiver to interrupt the data accurately, the signals must be sufficiently strong. But when the signal passes through the medium, they tends to get weaker. As it covers the distance, it loses its strength. And attenuation is one of the transmission impairment. Attenuation means loss of energy. Next, what is distortion? Distortion means the signal changes its shape. Signal changes its shape or form. So when the signal passes through the medium, the signal changes its shape or form. If the signal speed and frequency does not match, then there are possibilities that signal reaches destination in different shape or form. So this is called distortion. Distortion is also one of the transmission impairment. When the signal passes through the medium, it changes its shape or form because the signal speed and frequency does not match. So they reaches the destination with different shape. This is called distortion. Next question is, what is error, and explain burst error with example. So let us first see the definition of error. What is error? Error means the condition. Error is the condition when the receiver information does not match with the sender information during transmission. Receiver information does not match with the sender's information during transmission. Next, in the error, there is three types of errors: single bit error, multiple bit error, and burst error. Now we have to explain the burst error. Burst error means in the received frame, this is the send frame and this is the received frame. In the received frame, they contain more than one consecutive bits in corrupted state. So in the received frame, they contain more than one consecutive bits in corrupted state. So this is called the burst error. Next question is, mention the uses of computer network. So computer networks are widely used in everywhere. Some of the uses of computer networks are easy file sharing and resource sharing resource sharing, software sharing, and it acts as a communication medium, computer network. And next question is, mention the uses of computer network. So computer networks are widely used in everywhere. Some of the uses of computer networks are easy file sharing, easy file sharing and resource sharing, resource sharing, software sharing, and computer networks acts as a communication medium. It acts as a communication medium and used as a electronic commerce, used in electronic commerce, and flexible access among the computers, and interactive entertainment, used in interactive entertainment. And these are the uses of computer network. Next question is, what is hybrid topology? So hybrid topology is a type of network topology. So hybrid topology is a type of network topology, and this is a diagram of hybrid topology. This is a type of, and a network structure whose design contains more than one topology. A network structure whose design contains more than one topology is said to be hybrid topology. And hybrid topology inherits merits and demerits of all the incorporating topologies. It inherits merits and demerits of all the incorporating topologies. Means these topology can include the hybrid topology can include mix of bus topology, star topology, and ring topology, tree topology. So it is a mix of all the topologies. Hybrid topology is a mix of all the topologies. And internet is the best example of largest hybrid topology. And in network, most of the WANs are connected by means of ring topology, and networks connected to them are with the help of star topology. And internet is the best example for largest hybrid topology. Next question is, mention two difference between TCP/IP and Osi model. So let's see the difference. TCP/IP means transmission control protocol, Internet Protocol. So OSI means Open System Interconnection Model. Open System Interconnection Model. And TCP/IP is implementation of OSI model. TCP/IP is implementation of OSI model. And OSI is reference model. Next is the TCP/IP has only 4 layers. Has only 4 layers. And the OSI has 7 layers. And the TCP/IP is horizontal approach. It's horizontal approach. And the OSI model is vertical approach. So the difference between TCP/IP and OSI model is TCP/IP means Transmission Control Protocol and Internet Protocol. OSI means Open System Interconnection Model. And TCP/IP is a implementation of OSI model. And it is a reference model. And TCP/IP has only 4 layers and OSI has 7 layers. And TCP/IP is a horizontal approach, whereas OSI is a vertical approach. Next question is write any 2 functions of transport layer. So let's see the functions of transport layer. So among 7 layers in OSI, the transport layer is one of them. So the functions of transport layer are it makes process to process delivery. Process to process delivery. And congestion control. It controls the congestion. And flow control. Data integrity and error correction. End-to-end connection between host. These are the functions of transport layer. So the next question is difference between physical and logical addressing. So we see the difference between physical and logical addressing. So physical address means MAC address. MAC address system. MAC address means MAC means media access control. Media access control address. So physical address means system's MAC address. So logical address means IP addressing. IP addressing. So physical address cannot be changed. Cannot be changed. So logical address can be changed. Logical address can be changed. And physical address is working at layer 2 of OSI. Layer 2 of OSI. And logical address logical address working at layer 3 of OSI. So OSI has how many layers? It has 7 layers. 1, 2, 3, 4, 5, 6 and 7. So physical address working at the layer 2 of OSI model, and logical address is working at layer 3 of OSI model. And next question is, list any 2 disadvantages of coaxial cable. So let us see the disadvantages of coaxial cable. So coaxial cable is expensive. Coaxial cable is expensive because to install for longer distance, to install for longer distances due to its thickness and stiffness. So because it is too expensive, because the structure is very thick and stiffness, so it is difficult to install for long distances, and it is bulky. So this is the disadvantages of coaxial cable. Now I am going to solve the part B question, and the question is, explain the components of data communication. This diagram shows the components of data communication, and components of data communication are, first one is message, second one is sender, third one is receiver, fourth one is transmission medium, and fifth one is protocol. So as diagram shows, the 5 components of data communication are sender, receiver, message, and the transmission medium, and the protocol. First one is message. Here the message is the information. Or data to be communicated. So what is message means? Message is the information, whatever the message we sending to receiver, that is called message. The message is the information or data to be communicated from sender to receiver. So these information or this message may include text, numbers, pictures, video, audio. So this is the message. Next component is sender. Here sender is the device. That sends the data message. So it can be the sender can be a computer, workstation, telephone, handset and video camera. So here sender is the device. Sender is the device that sends the data message to the receiver. These sender may be computer, workstations and video camera and telephone handset. Next component is receiver. Here receiver is the device that receives the data message. Receiver is the device that receives the data message. It can be, the receiver can be either again the computer, workstation, telephone handset and video camera and so on. So examples, it can be a computer, workstation, video camera and so on. The third component is transmission medium. Here transmission medium is the physical path. By which message can travel from sender to receiver. Physical path by which message can be traveled. Message can be traveled from sender to receiver. Example, these transmission medium may be twisted pair cable, coaxial cable, radio waves, microwaves. So here transmission medium is the physical path by which message travels from sender to receiver. And the example, the twisted pair cable, coaxial cable and radio wave. And the next component is protocol. Here protocol is a set of rules to govern the data communication. For every sender to send the message or information, they follow some protocols. Means protocol is a set of rules. Is a set of rules that govern data communication. Means it represents the agreement between the communicating devices. It represents agreement between communicating devices. It represents the agreement between the communicating devices. Without protocol, two devices may be connected but not communicating. Without protocol, two devices may be connected but not communicating. Example, if a person speaking French cannot be understood by a person who speaks only Japanese. A person who speaks French cannot be understood by the person who speaks only the Japanese. That is called protocol. These are the 5 components of data communication. That is message, sender, receiver, transmission medium and protocol. Next question is, what is network topology, and explain star topology and ring topology with advantages and disadvantages. Let us first see the definition of network topology. Network topology. So network topology is the arrangement with which network topology is the arrangement with which computer system are network devices are connected to each other. So what is network topology? Network topology is the arrangement with which the computer system or network devices are connected to each other. Means, what is topology? Topology means how the systems are connected in a network. It is called topology. So next, the star topology. Star topology is one of the network topology, whereas in star topology all the hosts are devices. All the hosts are devices connected to a central device. Connected to a central device called hub. All the devices are connected to a central hub called device using point-to-point connection. That is, there exists a point-to-point connection between the host and the central hub. Between host and hub. This is what star topology. In star topology, each device is connected to a central hub and there is a point-to-point link between the device and the hub. Let's see the advantages of star topology. Star topology is less expensive. So each device needs only one link and input-output port to connect it to any number of others. Each device need only one link and input-output port to connect any number of devices. And next one is, it is robust. Means if one link fails, if only one link fails, only that device is affected. The other links remains active. If only one link fails, only that device fails. All remains active. Then next, easy for fault isolation and fault identification. And in star topology does not allow the direct traffic between the devices. It does not allow direct traffic between the devices because the controller acts as an exchange. The controller acts as an exchange. Example, if one device wants to send the device to another device which is not adjacent to it, then it sends the device sends the data to the controller, which then relays the data to another connected device. Understood? This is advantages of star topology. Next, disadvantages. So dependency of the whole topology on one single point, that is hub. If hub fails, the whole system is dead. So dependency of the whole topology. Dependency of the whole topology depends on one single point, that is called hub. If hub fails, the whole system fails. And more cabling is required in a star topology. So more cabling is used in star topology as compared to ring topology. This is the disadvantages of star topology. Another type of network topology, that is ring topology. So in ring topology, each host machine is connects to exactly two other machines and creating circular network structure. So each host machine connects to exactly two other machines and creating a circular network. Structure. When one host tries to communicate or send message to a host which is not adjacent to it, the data travels through all the intermediate hosts. So the data travels through all the intermediate hosts and then sends to the message. This is ring topology. Then advantages of ring topology: easy to install and reconfigure. And next one is fault isolation is simplified. Fast isolation is easy to find. Disadvantages: if any break in the ring can disable entire network. Because the host is a single point of failure. If any break or any fault in any ring, the whole system fails. This is the disadvantages of ring topology. Next question is explain transmission modes with examples. So communication between two devices can be simplex, half duplex and full duplex. So there are three transmission modes: simplex transmission, half duplex and full duplex transmission. So first one is simplex transmission. In simplex mode, the communication is unidirectional. So in simplex mode, the communication is unidirectional. So only one of the two devices, on a link, can transmit. The other can only receive. So simplex mode is unidirectional. Only one of the two devices on a link can transmit, other can only receive. So keyboard and monitors are the examples of simplex devices, because in keyboard we can only introduce the input. In monitor we can only accept the output. Only one of the two devices on a link can transmit. That is called simplex mode. And the simplex mode can use entire capacity of the channel to send data in only one direction. So entire capacity of the channel to send the data in only one direction. For example, radio and television broadcasters. This is called simplex transmission. And second transmission mode is off duplex mode. In off duplex mode, each station can transmit and receive. So in off duplex mode, both stations can transmit and receive, but not at the same time. Both stations can transmit and receive, but not at the same time. When one device is sending, other can only receive, and vice versa. One device is sending, other can receive, and vice versa. So off duplex mode is like a one lane road with traffic allowed in both directions. So off duplex mode is like a one lane road with traffic allowed in both directions. Example, car are traveling in one direction and the car going in another direction must wait. The car traveling in one direction and the car going in the other way must wait. That is called off duplex mode. And in off duplex mode, the entire capacity in half duplex mode. The entire capacity of the channel is taken over whichever of the two devices is transmitting at the time. So the entire capacity of the channel is taken over whichever of the two devices is transmitting at the time. An example for off duplex is walkie-talkie. This is called off duplex transmission. Third transmission mode is full duplex mode. In full duplex mode, both station can transmit. Both station can transmit and receive simultaneously. The full duplex mode is like a two-way street with traffic flowing in both the direction. Full duplex mode is like a two-way street with traffic flowing in both the direction at the same time. So example of full duplex mode is telephone network. When two people are talking via telephone, both can talk and listen at the same time. Example, when two people are communicating by the phone line, both people can talk and listen simultaneously or at the same time. This is about full duplex transmission. Both can transmit and receive simultaneously. Next question is, what are the characteristics of data communication? For effective data communication, the system must depends on the fundamental characteristics. Those are, first one is delivery, second one accuracy, third one timeliness, and fourth one is jitter. Let's see one by one. First one is delivery. For effective data communication, delivery is most important. The system must deliver the data or message to the correct destination. So system must deliver the data or information to the correct destination. Second one is accuracy. So the system must deliver the data without error. The system must deliver the data without error and accurately. Then data communication will be effective. Then third one is timeliness. The system must deliver the data in a timely manner. The data received late are useless. So the system must deliver data in a timely manner, and the data received with late are useless. So timeliness is very important characteristic. Then Fourth one is jitter. And the next characteristics is jitter. Jitter is the variation in the packet arrival time. Variation in the packet arrival time means it is uneven delay in the delivery of, and also it is the uneven delay in the delivery of audio or video packets. For example, if the video packets are sent with every 30 minutes, if some of the video packets arrive with 30 minutes delay and some other with 40 minutes delay, so what is the result? Uneven quality. Uneven quality is the result. This is called jitter. These are the 4 characteristics of data communication. Next question is, what is guided media? Explain with examples. So guided media defined as the physical medium through which the signals are transmitted. So it is also known as bounded media. So whereas in guided media, the physical media through which these electromagnetic signals are transmitted. So examples of guided media are twisted. Guided means with the help of wires, the message is travelled from sender to receiver. With the help of twisted pair cable. Second one is coaxial cable. And third one is fiber optics. First one is twisted pair cable. And this is twisted pair cable. A twisted pair cable is made up of 2 plastic insulated copper wires twisted together to form a single media. Out of these 2 wires, only one carries the actual signal and another one is used for ground reference. So the twist between the wires are advantageous to twisted pair cable because the twist between the wires are helpful in reducing noise and crosstalk. So it is made up of 2 plastic insulated copper wire, 2 plastic insulated copper wire and twisted together to form a single media. So out of these 2 wires, only one carries actual signal and another is used for ground reference. So the twist between the wires are helpful in reducing noise and crosstalk. and crosstalk. So crosstalk means the disturbance, crosstalk, the disturbance caused by electric or magnetic fields in a telecommunication signal that affecting a signal in an adjacent circuit. That is called crosstalk. There are two types of twisted pair cable. First one is shielded twisted pair cable, and second one is unshielded twisted pair cable. We call it as STP and UTP cables. So STP cables comes with twisted wire pair. Twisted wire, that pair covered with metallic foil. This twisted wire pair covered with metallic foil, it makes more indifferent to noise and crosstalk. They avoid the noise and crosstalk. And UTP. So UTP has 7 categories. Category 1, Category 2, Category 3, Category 4, Category 5, Category 5E, and Category 6. There is a 7 categories in unshielded twisted pair cable, and each suitable for specific use. Out of these categories, Category 5, Category 5E, and Category 6 cables are mostly used. These 3 categories are mostly used. And UTP cables are connected by RJ45 connectors. RJ means registered jack. These UTP cables are connected by RJ45 connector. This is the structure of twisted pair cable. And second type of guided media is coaxial cable, and structure of coaxial cable is the coaxial cable is made up of 2 wires of copper, and the core wire, this is the core wire, lies in the center, and it is made up of solid conductor, and this core is enclosed in an insulating sheath. This is an insulating sheath. The core is enclosed in an insulating sheath, and the second wire wrapped around the insulating sheath. The second wire is wrapped around an insulating sheath, and the core and the second wire all are in turn encased by another insulating sheath. The core and second wire again enclosed in an insulating sheath, and this all is covered by a plastic cover. This is the structure of coaxial cable. Means coaxial cable has 2 wires of copper, and the core lies in the center. And it is a solid conductor, made up of solid conductor, and the core is enclosed in an insulating sheath. And the second wire is wrapped around over the sheath, and the core wire and the second wire, these two in turn enclosed in an insulating sheath. So this all covered with one plastic cover. So because of this structure only, the coaxial cable is capable of carrying high frequency signals than that of twisted pair cable. And this wrapped structure provides good shield against noise and crosstalk. So because of this rough structure only, the coaxial cable carrying high frequency signals than that of the twisted pair cable, and this wrapped structure provides good shield against noise and crosstalk. And coaxial cable provide high bandwidth up to 450 Mbps. They provide high bandwidth up to 450 Mbps. And there are three categories of coaxial cable. First one is RG59. RG means radio government. RG58 and RG11. So RG59 is used for cable TV, and RG58 is used for thin Ethernet, and RJ11 is for thick Ethernet. So these are the three categories of coaxial cable. First one is RG59 for cable TV, RG58 for thin Ethernet, RG11 for thick Ethernet. In coaxial cable, cables are connected using BNC connector, and BNC T connector, BNC terminator is used to terminate the wires at far end. So this is coaxial cable. The next guided media is fiber optics. So this is the structure of fiber optics. Mainly fiber optics works on the properties of light. Means it works on the properties of light. Then what is the properties of light? When some light ray hits at some critical angle, it tends to refract at 90 degrees. What is the properties of light? When some light ray hits at some critical angle, it tends to refract at 90 degrees. So this is the properties of light. What is the properties of light? When light ray hits at critical angle, it tends to refracts at 90 degree. So this property is used in fiber optic. And let's see the structure of the fiber optic. The core, this is the core. The core is made up of high quality glass or plastic. This core is made up of high quality glass or plastic. Then from one end of light is emitted, it travels through it, and at the another end light detector detects light stream and converts it to electric data. So this is the property of light. When one end of the light is emitted, it travels along it, and at another end light detector detects light stream and then it's converted to electric data. And fiber optic provide highest mode of speed. It provides highest mode of speed, and it comes in two modes. Fiber optics comes in two modes. First one is single mode fiber, and second one is multi-mode fiber. So single mode, the single mode can carry single ray of light. Multi-mode carry multiple beams of light. And there are two types of modes, single mode and multi-mode. Then fiber optic also comes in unidirectional and bidirectional capabilities. So to the user, to access and connect optical fiber, a special type of connectors are to connect and access. The users are use special type of connectors. These connectors are straight tip, ST, and subscriber channel. That is called SC. Then what is the use of fiber optics? So some cable TV companies use a combination of optical fiber and coaxial cable for creating a hybrid network. So fiber optics are used in some cable companies to create a hybrid network. This is all about fiber optics. In part B, the next question is explain baseband and broadband transmission. So in computer network, you see what is baseband transmission. So baseband transmission typically use digital signaling over a single wire. Means it use digital signaling over a single wire. Means it uses digital signal, whereas broadband transmission uses analog signal in the form of optical or electromagnetic waves. In the optical or electromagnetic waves. So whereas the baseband signal uses for transmission digital signaling and broadband signal uses analog signal for transmission. And see the difference between baseband and broadband transmission. So first one is baseband transmission uses digital signaling, analog signaling. Second one is baseband is bidirectional transmission. The transmission is bidirectional. In baseband transmission. In broadband transmission, the transmission is unidirectional. And here signals cover or travel shorter distance. It covers short distance. The baseband signals cover short distance, whereas in broadband the signal traveling distance is long. And the fourth one is here the entire bandwidth is for whatever the bandwidth used in the baseband is for single signal transmission. The whole bandwidth it's used for only the single signal transmission, whereas in broadband simultaneous transmission of multiple signals. In baseband signal, single signal. In broadband signal, multiple signals over different frequencies. The entire bandwidth is for only single signal transmission, whereas in broadband multiple signals over different frequencies. Example for baseband is, so Ethernet is use baseband LAN. Baseband LAN. So baseband is used in Ethernet. Example for broadband is used to connect table used to connect cable TV to premises. Cable TV to premises. This is the difference between baseband and broadband transmission in computer network. Next question is differentiate between bitrate and baud rate. So bitrate and baud rate are important in communication. Let's see the difference between bitrate and baud rate. First one, let's see the definition. Bitrate is the number of bits. Bitrate is the number of data bits. Number of data bits transferred per second. Baud rate is the number of signals. Your data bits, your signals are voltage level changes per second. So bitrate is the number of data bits transferred per second. Your number of signals or voltage level changes per second. Next is unit of bitrate is bits per second. Bits per second. BPS. The unit of baud rate is baud per second. Baud per second. And the formula for bitrate, to determine the bitrate, is bitrate equals baud rate into number of bits per baud. Bitrate is equal to baud rate into number of bits per baud. The formula for baud rate is bitrate divided by number of bits per baud. Bits per baud. And the next difference is, in bitrate it cannot determine the bandwidth. Baud rate can determine how much bandwidth is required to send the signal. So here it cannot determine the bandwidth, it determines the bandwidth and how much bandwidth is required to send the signal. Bitrate mainly focuses on computer efficiency. It mainly focuses on computer efficiency, whereas baud rate mainly focus on data transmission. Mainly focus on data transmission. Example for bit rate is, if the bit rate is 1000 bps, means then 1000 bits are transferred per second. Baud rate example, the baud rate is 9600 bps, means 9600 signal levels. 9000 signal level changes within a second. So baud rate is 9600 bps, means 9600 signals are change its state. That is baud rate. In part B, next question is, explain modulation techniques with need diagram. The modulation technique is also called as analog to analog conversion. So let's see the definition. Modulation definition. What is modulation? So modulation is the process of converting data into radio waves by adding information to an electronic or optical carrier signal. So modulation is the process of converting data into radio waves by adding information to an electronic or optical carrier signal. Modulation is the process of converting data into radio waves by adding the information into some carrier signal. By adding information to carrier signal. This carrier signal is a steady wave. Carrier signal is a steady waveform that contains amplitude and frequency. It is a steady wave that contains amplitude and frequency. So this is called as modulation. And analog to analog conversion can be divided into 3 types. First one is amplitude modulation, frequency modulation, and phase modulation. These conversion can be categorized into three types: amplitude modulation, frequency modulation, and phase modulation. These are the three techniques in modulation. So this is first one is amplitude modulation, and this is the modulating signal, and this is carrier signal, and this one is modulated signal. The alpha of carrier signal, the modulating signal is changed to the signal. So in amplitude modulation, the amplitude of the carrier signal is modulated to reflect amplitude of the modulating signal. So in amplitude modulation, the carrier signal is modulated so that its amplitude means height. See, the height is different in each wave, so that its amplitude varies with the changing amplitude of the modulating signal. So in amplitude modulation, amplitude of the carrier signal is modulated to reflect amplitude of the modulating signal. So in amplitude modulation, the frequency and phase of the carrier remain constant. So in amplitude modulation, the amplitude changes with the modulating signal. This is amplitude modulation. And second type of modulation is frequency modulation. This is the modulating signal, and this is the carrier frequency, means carrier wave, this is steady wave, and this is the modulated frequency signal. So in amplitude modulation, amplitude of the carrier signal is modulated, and frequency and phase remains constant in amplitude modulation. Whereas in frequency modulation, frequency of the carrier signal is modulated. To follow changing voltage levels of the modulating signal. Changing voltage level of the modulating signal. So in FM means frequency modulation, the peak amplitude and phase of the carrier signal remains constant. Amplitude and phase of the carrier signal remains constant. Here only frequency changes, but the amplitude means height and phase remains constant in frequency modulation. Next type of modulation is phase modulation. This is the modulating signal, carrier signal, and phase modulated signal. So phase of the signal is modulated. In amplitude of the signal is modulated. In frequency of the signal is modulated. In phase modulation, phase of the signal phase of the signal. So different waves, two or more occurrences have different waves. So in phase modulation, phase of the carrier signal is modulated. Modulation, phase of the carrier signal, phase of the carrier signal is modulated to follow changing voltage levels of the modulating signal. To follow changing voltage levels of the modulating signal. So in phase modulation, the amplitude and frequency remains constant. But phase is modulated to reflect change in voltage levels of the modulating signal. Amplitude and frequency remains constant in phase modulation. These are the three techniques of modulation: amplitude, frequency and phase modulation with diagram. Next question is, describe OSI model and explain the functions of physical and presentation layer. So OSI means open system interconnection model. So OSI has totally 7 layers: the physical, data link, network, transport, session, presentation and application layer. So the main purpose of OSI model is to show how to facilitate communication between two different systems. Without requiring changes to the logic of hardware and software. Underlying of hardware and software. So the main purpose of the open system interconnection model is to show how to facilitate the communication between the different systems without requiring changes to the logic of underlying hardware and software. The OSI model is not a protocol, but it is a model for understanding. And designing a network architecture. That is flexible, robust and interoperable. So it is not a protocol, but it is a model for understanding and designing network architecture that is flexible, robust and interoperable. So here we have to explain the physical and presentation layer. The first layer is physical layer and it is the lowest layer in the OSI model, that is the lowest layer in the physical layer. So physical layer mainly concerned with the physical layer is mainly concerned and responsible for movements of individual bits. It is responsible for movement of bits. It is mainly responsible for movement of individual bits from one system to another system, or one hop to next hop. And the physical layer coordinates the physical layer coordinates the function coordinate the function, and it's coordinate the function and required to carry bit stream over a physical medium. Means it is responsible for carrying of bits over a physical medium. And physical layer also deals with the mechanical and electrical. So it is first one is it's carry bit stream over a physical medium, that also responsible for mechanical and electrical specification of the interface and transmission medium. So the physical layer coordinates the function that required to carry the bit stream over a physical medium. It also responsible for mechanical and electrical specification of the interface and the transmission medium. And the main functions of physical layers are: first one is physical characteristics of the interface and the medium, and representation of bits, data rate, synchronization of bits, line configuration, and physical topology and transmission mediums. In the physical characteristics of the interface and medium, so the physical layer defines the characteristics of the interface between the devices and the transmission medium. And also physical layer defines the type of the transmission medium. The physical layer is also responsible for representation of bits. Means the physical layer data consists of stream of bits with no interpretation. To be transmitted, bits must be encoded into signals. So electric or optical. The physical layer defines the type of encoding, and the physical layer also defines the type of encoding. And the physical layer is also responsible for data rate. Data rate means the number of bits sent each second. Is also defined in physical layer, and it also responsible for synchronization of bits. The sender and receiver not only must use the same bit rate but also must be synchronized at bit level. So sender and receiver clock must be synchronized. And also the physical layer is responsible for line configuration. The physical layer is concerned with the connection of devices to the media. In line configuration, they have point-to-point configuration and multi-point configuration. In point-to-point configuration, two devices are connected to a dedicated link, whereas in multi-point configuration, the link is shared among several devices. There are two types of line configuration: point-to-point and multi-point. So the physical layer is responsible for configuration. And next one is physical topology. Physical topology means how the devices are connected in a network. How the devices are connected in a network, either mesh, bus topology, star topology, ring topology, tree topology, hybrid topology. It is also responsible for the physical topology. And the last one is transmission modes. The physical layer also defines the direction of transmission between two devices. Transmission mode also responsible for transmission between two devices. The direction of transmission between two devices, either simplex, half duplex or full duplex. Simplex, half duplex or full duplex. So the physical layer is responsible for synchronization of bits, line configuration, physical topology, data rate, representation of bits, and physical characteristics of the interface and medium. In Osi model, the sixth layer is presentation layer. So the present layer is mainly concerned with the syntax and semantics of the information exchanged between two systems. Information exchanged between two systems. And presentation layer also responsible for encryption, this provides encryption, compression, data compression, and code conversion. Means convert data from binary to ASCII, ASCII to BCD, and etc. And it provides error control and flow control. So the presentation layer mainly concerned with syntax and semantics of the information exchanged between two systems, and also it provides the encryption, compression, and code conversion, and it provides error control and flow control. And some of the responsibilities of presentation layer are translation. So the process are in running programs. Two systems are usually exchange their information in the form of string, text, numbers, character. So in the form of string, number, character, and so on. The information must be changed. To bit streams. So this information must be changed to bit streams before being transmitted. Because different computers use different encoding systems. So Before transmission, these characteristics must be converted into bit streams. So the presentation layer is responsible for interoperability between these different encoding systems, encoding system. So translation is very important. Whatever the string character must be exchanged to bit streams before being transmitted. The next responsibility is encryption. So to carry sensitive information, a system must be able to ensure to carry sensitive information. System must ensure privacy. So encryption means the sender transforms the original information. The sender transforms whatever the original information is there, that sends to the another form, and sends the resulting message over the network. So decryption is the reverse of the encryption. So encryption means to protect the sensitive information that transforms the original information to another form and sends the resulting message over the network. Next responsibility in presentation layer is compression. What is compression? So data compression reduces the number of bits contained in the information. That reduces number of bits contained in the information. So data compression is particularly important in the transmission of multimedia. It is important in the transmission of multimedia such as text, audio, and video. So these are the responsibilities of presentation layer: translation, encryption, and compression. Next question is difference between analog and digital signal. So let's see the definition. Analog signals are continuous waveform in nature. Continuous waveform. Value with time. And digital signals are discrete. It is discrete in nature. They consist of 0 and 1 values. So analog watch is the example. Analog watch example. It is continuous waveform in nature. For digital watch is the example for digital signal. It is fixed, consists of zeros and ones. And next difference is it has higher error rate. And digital signal has low error rate. And analog signals has size limitations, but digital signals has no size limitations. And analog signals cheap, discrete digital are expensive, and these analog signals can be distorted with noise. It can be distorted with noise. It has digital signals has reliability and privacy and no disturbance. It cannot be distorted with noise or anything. No disturbance in digital signal. And in analog signal, there is a slow transmission. Slow transmission. In digital signal, fast transmission. So this is the difference between the analog and digital signal, and it can have infinite number and it has limited number of values in digital. Next question is explain digital to analog conversion with neat diagram. Please remember, for analog to analog conversion, there is 3 types of modulation techniques: amplitude, frequency and phase. This is digital to analog conversion. So when data from one computer to another computer via some form of analog carrier, it is first converted into analog signal. When data from one computer to another computer sent via some analog carrier, it is first converted into analog signals. Then analog signals are modified to reflect digital data. So analog signals are characterized by amplitude, frequency and phase. These are the characters of analog signal. And there is 3 kinds of digital to analog conversion. First one is analog to analog conversion. There are 3 types of analog conversion. First one is amplitude shift keying. Then frequency shift keying and phase shift keying. These are the 3 techniques in digital to analog conversion. And the first technique in digital to analog conversion is amplitude shift keying. So in this conversion technique, the amplitude of the analog carrier signal is modulated to reflect binary data. So in this conversion, the amplitude of analog carrier signal is modified to reflect binary data. So in this conversion, amplitude of the analog carrier signal is modified to reflect the binary data. When binary data digit represent 1, when binary data represent 1, the amplitude is held. When it is set to 0, there is no amplitude. So this is the method of amplitude shift keying. Means when binary data digit represent 1, the amplitude is held. Otherwise there is set to 0. So the binary data is 1, the amplitude is held. The binary data is 0, there is no amplitude, and the binary data is 1, amplitude is set, and there is no amplitude. This is the method of amplitude shift keying. And in amplitude shift keying, the frequency, both frequency and phase remains same. So as in the original carrier signal. Means it is remains constant, only amplitude changes. In digital to analog conversion, amplitude shift keying is one of the conversion method. Next conversion technique is frequency shift keying. So in frequency shift keying, the frequency of the analog carrier signal is modified to reflect binary data. So whereas in amplitude shift keying, amplitude of the analog carrier signal is modified to binary data. In frequency shift keying, frequency of the analog carrier signal is modified to reflect binary data. In this technique, they uses two frequencies, F1 and F2. So for example, this is 1, 0, 1, 0 and 1. For example, binary digit 1 is represented as F1 and binary digit 0 is represented as F2. So two frequencies are used, F1 and F2. F1 is used to represent binary digit 1 and F2 is used to represent binary data 0. And in frequency shift keying, amplitude and phase of the carrier wave kept constant. Phase of the carrier are constant. So in this conversion, the two frequencies are used, F1 and F2. F1 is used to represent binary digit 1 and F2 is used to binary digit 0. This is F1 and this is F2. This is frequency shift keying. Third conversion technique is phase shift keying. So whereas in amplitude of the carrier signal is modulated to reflect binary data, and in frequency shift keying, frequency of the original carrier signal is altered to reflect binary data, and in phase shift keying, phase of the, in this conversion, phase of the original carrier signal is altered to reflect binary data. So in this conversion, when new symbol is encountered, the phase of the signal is altered. When new symbol, there is a new symbol is altered, the phase of the signal is altered. See here, this is 1. Here the phase of the signal is altered, so binary data 0. Here there is no change 1 binary data, and there is no change 1. Here the phase of the symbol is altered, so it represents as 0. When new binary symbol is encountered, the phase of the signal is altered. And in phase shift keying, the amplitude and frequency of the original carrier signal is constant. So please keep it in mind. In phase shift keying, when new binary symbol is encountered, the phase of the signal is altered. This is phase shift keying. These are the 3 conversion. First one is amplitude, second one is frequency, and third one is phase shift keying. Next question is explain flow control mechanism. So the flow control comes under data link layer. So data link layer is responsible for implementation of this data link layer. The OSI has 7 layers, and the second layer is data link layer. Data link layer is responsible. This data link layer is responsible for implementation of point-to-point flow, and error control mechanism. The data link layer is responsible for flow control. Then what is flow control? When data frame is sent from sender to receiver. This information, maybe data is sent from one host to another host, or one system to another system over a single medium. So it is required that the sender and receiver must work at the same speed. When data frame is sent from one device to another device, it is required the sender and receiver should work at same speed. Sender and receiver work at same speed. Means the sender sends at a speed on which the receiver can process and accept the data. That speed should be same. But the sender is sending too fast. The sender is sending the data too fast. The receiver may be overloaded. If speed is not matched, means the receiver may be overloaded with the data, and data may be lost. So to control this control of flow, 2 mechanisms are used. To control the flow of data, 2 mechanisms can be used to control the flow of data stream, flow of data stream means when a data frame is sent from one computer to another computer, it is required that the sender and receiver should work at the same speed. But the sender, it's sending too fast, the receiver may be overloaded because the receiver can process and accept the data does not match with the sender speed. So these two mechanisms are used. First one is stop and wait mechanism, stop and wait. Second one is sliding window. These two mechanisms are used to control the flow of data. First mechanism is stop and wait. So this flow control mechanism forces the sender after transmitting the data frame to stop and wait until the acknowledgement of the data frame sent is received. So what is stop and wait? The sender forces after transmitting the data frame to stop and wait until the acknowledgement of the ACK means acknowledgement, frame means data frame. After acknowledgement of the data frame sent is received. This is called stop and wait. So this stop and wait mechanism forces the sender after transmitting a data frame to stop and wait until the acknowledgement of the data frame sent is received. Until the acknowledgement of the data frame sent is received. So after getting the acknowledgement only, then start sending new frames to the receiver. So this is stop and wait mechanism. Next mechanism of flow control mechanism is sliding window, and this is the diagram of sliding window. This is the sender and receiver. So with stop and wait protocol, the first mechanism is stop and wait. With stop and wait protocol, the sender waits for an acknowledgement after transmitting each frame. So what we have done in stop and wait, after transmitting each frame, we have to wait for an acknowledgement. So in stop and wait, what we have done, the sender waits for an acknowledgement after transmitting each frame. So what happened, most of the time the network will be completely idle. Most of the time the network completely idle. So the main key feature of sliding window is that the sliding window permits the streamed communication. It permits streamed communication. Communication means it allows the sender to transmit multiple packets before waiting for an acknowledgement. It allows the sender to transmit multiple packets before waiting for an acknowledgement. Before waiting for an acknowledgement. So in stop and wait, the sender waits for an acknowledgement after transmitting each frame, but in sliding window it allows sender to transmit the multiple packets before waiting for an acknowledgement. So here the transmission of 3 packets can look like this. Transmission of 3 packets. After transmitting the multiple packets, then only the receives the acknowledgement. So the most of the resources are usable here. Most of the resources are usable in sliding window. And in sliding window, the sequence and acknowledgement numbers used. So in this way, sliding window works to control the flow of data. And these are the 2 mechanisms in flow control. First one is stop and wait and sliding window. Next question is explain the types of errors and error detection and correction methods. The types of errors are So error means the condition when the receiver information is not matched with the sender information during transmission. So types of errors are single bit error, multiple bits error, and burst error. In single bit error, in the this is the send frame and this is the received frame. In the received frame, only one bit in corrupted state. So in the frame there is only one bit anywhere which is corrupt. That is called single bit error. Only one bit anywhere which is corrupt. That is called single bit error. In multiple bit error, the frame, this is the send frame and this is the received frame. In the received frame, with more than one bits in corrupted state. More than non-consecutive bits in corrupted state. So the frame is received with more than one bits in corrupted state. In burst error, the frame contains more than one consecutive bits in corrupted state. Frame contain more than one consecutive bits in corrupted state. So these are the types of errors according to network: single bit error, multiple bit error, and burst error. Next is error detection methods. So the errors in the received frame. Errors is the send frame and this is the received frame. This is the send frame. Errors in the received frames are detected by means of parity check and cyclic redundancy check. So in both cases, in both parity and cyclic redundancy, one or few extra bits are sent along with the actual data. So few extra bits are sent with actual bits to confirm the bit received in another end as the same as the sent. If the counter check at the receiver end fails, then bits are considered to be corrupted. Means what we done in error detection, few extra bits are sent along with the actual data to confirm that whether the received frame is same as the sent frame. If the receiver end it fails, then the bits are considered to be corrupted. In parity check, one extra bit is sent along with the original bits to make the number of ones either even in case of even parity or odd in case of odd parity. So this is the data bits 100101. So while creating the data frame, the sender first count the number of ones in the data bits. So number of ones in the data bit is 3. So it is odd parity. So with the original bit they add odd parity. With the actual data bits they add one extra bit along with the original bits. And first count the number of ones in the data bits. If number of ones is even, add even parity has 0 and counts the number of ones it is odd parity, then 1 is added. So in case of even parity 0 and in case of odd parity it must add 1. So in this case the number of ones is odd, so here we added 1 as even parity. This is so the sender while creating the bits they checks the number of ones in it. For example, if even parity is used and the number of 1 is even, then 1 bit with value 0 is added. So and this way the number of ones is remains even if the number of ones is odd. To make it even, a bit with value 1 is added. So after adding, at the receiver side they counts the number of ones in a frame. So if the count of 1 is even and even parity is used, the frame is considered to be not corrupted. Here the number of ones is odd and odd parity is used. So it is considered to be not corrupted. So this is parity check method to detect the error in the received frame. Main concept is first counts the number of ones in the data frame. If the number of ones is even, then even parity is added as 0, and count the number of ones it is odd, then add extra 1 bit as 1. So after receiving the frame, the receiver counts the number of ones in the frame. If the count of 1 is even, in the case of even parity is used, then the frame is considered to be not corrupted. And if the count of 1 is odd and odd parity is used, the frame is not corrupted. This is all about error detection. Next technique to detect the error is cyclic redundancy check, and it is a different approach to detect the received frame contains valid data or not. So this technique involves the binary division of the data bits being sent. Whatever the sent bit is there, they perform the binary operation. This is the binary operation. So the divisor is generated using polynomials, and the sender performs the binary division operation on the bits being sent. These are the bits being sent, and calculate the remainder. This is the remainder before sending the actual bit. The sender adds, before sending the actual bits to the receiver, they adds the remainder at the end of the actual bits. For example, this is the data bit 11001. After that, they add the remainder at the end of the actual bits. Actual data bit, so actual data bit plus remainder is called as code word. The actual data bit and the remainder is called as code word. The sender transmits a data bits. The sender transmits data bits as code words. After sending the code words to the receiver performs the binary operation on code words. Code word is data bit plus CRC as code word. So at the receiver side, they perform the division operation using the same CRC divisor. So if the remainder contains all the zeros, then the data bits are accepted. Means there is no error in the received frame. This remainder not contains 0 means there is some data corruption occur in the transist. There is some corruption occurred in the transist, in the transit. This is the cyclic redundancy check. In this way, we have to identify the error in the received frame. Next is error correction. So in network, error correction can be done in 2 ways. First one is backward error correction, and second one is forward error correction. So in backward error correction, so when the receiver detects, this is the send frame and this is the received frame. When the receiver detects an error in the data received, detects an error in the data received. It requires that request back the sender to retransmit the data unit. So the sender for the receiver, it requests the sender to retransmit the data unit again. So this is backward error correction. So backward error correction means when the receiver detects an error in the data received, it required to request the sender to send back to the data unit to retransmit the data unit. Retransmit the data unit. The sender then again retransmit the data frame. This is backward correction. In forward correction, second one is forward error correction. So when the receiver detects some error in the data received, it executes only the error correcting code. In forward, it executes again the error correcting code. Error correcting code. So which helps to recover and correct some kinds of errors. It helps to recover, auto recover, and to correct some kind of errors. So when in backward error correction, it is simple and can only efficiently use where the retransmission is not expensive. So backward error correction is used where the retransmission cost is not expensive. For example, backward error correction is used in fiber optics. Backward error correction is used in fiber optics, but in forward error correction, in the case of fiber optics, it's easy, but in the case of wireless transmission, retransmitting is too costly. Retransmitting is too costly in the case of wireless transmission. So on that case, the forward error correction is used. This is the two techniques used in error correction techniques. So this is your first model question paper. Please be prepared and read well for the examination with the help of these videos, and all the best for your exam, and thank you students.